Hello students, hope you are doing well. In this video, we are going to discuss network hierarchy, part 2 of unit 2, structuring and modularizing network for the subject enterprise network design of B7 semester IT University of Mumbai. In this lecture, we will cover distribution layer functionality, core layer functionality, and hierarchical routing in the WAN. And hierarchical network model and access layer functionality, it has already covered in network hierarchy. This diagram shows hierarchical network model. So here we are going to discuss distribution layer functionality. The distribution layer represents both a separation between access layer, this access layer, and the core layer, and a connection point. It is a connection point between the diverse access sites and the core layer. The distribution layer determines work group access. It determines the work group access and provides policy based connectivity. Distribution layer characteristics. The first characteristic is distribution layer provide control access to resource that are available at the core layer and must therefore use bandwidth efficiently. First thing is bandwidth efficiently. In campus environment, the distribution layer aggregates wiring closet bandwidth by concentrating multiple low-speed access links into high-speed core link and using switches to segment work group and isolate network problems to prevent them from affecting the core layer. Similarly, in a WAN environment, the distribution layer aggregates WAN connections at the edge of campus and provide policy-based connectivity. This layer provides redundant connections for access devices. Redundant connection also provides the opportunity to load balance between the devices. The distribution layer represents a routing boundary between access and core layer and is therefore and is where routing and packet manipulation are performed. The distribution layer allows the core layer to connect diverse sites while maintaining high performance. To maintain good performance in the core, the distribution layer can redistribute between bandwidth intensive access layer routing protocol and optimized core routing protocol. Route filtering is also implemented at this distribution layer. So important thing is filtering, route filtering. The distribution layer can summarize routes from access layer to improve routing protocol performance. For some network, the distribution layer offers a default route to access layer routers and run dynamic routing protocol only when communicating with core routers. The distribution layer connects network services to the access layer and implements policies for QoS or quality of services, security, traffic loading, and routing. For example, the distribution layer addresses different protocols, quality of services needed by the implementing policy-based traffic control to isolate backbone and local environment. Policy-based traffic control prioritize traffic to ensure the best performance for the most time-critical and time-dependent application. The distribution layer is often the layer that terminates access layer virtual LANs broadcast domain. However, this can also be done at the access layer. This layer provides any media transitions, for example, between Ethernet and ADM that must occur. Policy-based connectivity. It means implementing the policies of the organization. So we have already shown the policies in video number 4 to video number 9. So there are several methods for implementing policies. First thing is filtering by source or destination address. Second policy is you can filter based on input and output ports. Hiding internal network numbers by route filtering. Next, providing specific static routes rather than using routes from the dynamic routing protocol. Fifth one is the security. For example, certain packets might not be allowed into a specific part of the network. And finally, quality of services mechanism. For example, the precedence and type of services values in the IP packet headers can be set in routers to leverage queuing mechanism to prioritize the traffic. So these are the policy-based connectivity of the organization. So let us now discuss distribution layer functioning, how distribution layer functioning can be performed. So this shows the multi-layer switches. Here there are several multi-layer switches in between distribution and core layer and access layer. So access layer is having 4 multi-layer switches, and distribution and access and core layer is having 2 switches, and for core layer there are only 2 multi-layer switches. So there are protocols also: routing information protocol version 2 and enhanced interior gateway routing protocol. So each of these is having a specific functioning: multi-layer switching in writing closet, route filtering towards the access layer, routing boundary concentration of access attachment, packet filtering and policing, and route summarization, eventual load balancing, and multi-layer switching in the code. So how this thing can be done with the help of multi-layer switching. So multi-layer switching is used towards the access layer, and in this particular case within the access layer also. Multi-layer switching is performed in distribution layer and extended towards the core layer. You can see here in this diagram. The distribution layer performs two-way route redistribution to exchange the routes between routing information protocol version 2 and enhanced interior gateway routing protocol routing process. So route filtering is configured on the interface towards the access layer. Access layer, here it is route filtering is done. Now route summarization is configured on the interface towards the core layer. So route summarization towards the core layer and route filtering towards the access layer. The distribution layer contains highly redundant connectivity both toward the access layer and towards the core layer. Okay, so redundancies are there. Multi-layer switches are already implemented in all the layers. So multi-layer switching is very easy, and this give a redundant connectivity. Core layer is the last layer in the network hierarchy. So let us discuss core layer functionality. The core layer is high speed backbone. It is high speed backbone that should be designed to switch packet as quickly as possible to optimize com communication transport within the network. Because the core is critical for connectivity, core layer devices are expected to provide high level of availability and reliability. A fault-tolerant network design ensures that the failure do not have a major impact on network connectivity. The core must be able to accommodate failures by rerouting traffic and responding quickly to changes in the network topology. The core must provide a high level of redundancy. A full mesh is strongly suggested. If it is not available, then at least a well-connected partial mesh with multiple paths from each device is required to maintain the redundancy. The core layer should not perform any packet manipulation, such as checking access list or filtering, which would slow down the switching of packet. So no intelligent work will be performed here. The core layer must be manageable, and the core devices must be able to implement scalable protocol and technologies and providing alternative path and load balancing. Switching in the core layer. So let us discuss how switching is provided in core layer. So this particular example shows campus core. Okay, it is very small area network, or you can say local area network for 5 to 10 kilometers wide. So here it is access, distribution and core layer, and different switches are there. So these are the multi-layer switches between the distribution core and access layer. Okay, so layer 2 switching or multi-layer switching, this is also known as routing, can be used in the core layer because core devices are responsible for accommodating failures by routing traffic and responding quickly to network topology changes. And because performance for routing in the core with the multi-layer switch incurs at no cost, most implementation have multi-layer switching in the core layer. The core layer can then more readily implement scalable protocol and technologies and provide alternative path and load balancing. So these are our objectives. So how we can achieve the switching in core layer. So initially we start with packet is layer 2 switch towards distribution switch. So layer 2 switch towards distribution switch. The distribution switch performs multi-layer switching towards a core interface. So this performs multi-layer switching towards a core interface. The packet is layer 2 switch across the LAN core. The receiving distribution switch performs multi-layer switching towards an access layer. So towards an access layer, the packet is layer 2 switch across the access layer LAN to the destination host. So this is how we can perform the switching in core layer. This diagram shows multi-layer switching in the campus core. Implementation of this can be done with the help of multi-layer switches at the distribution layer and core layer also. So distribution layer routers peer with core routers and exchange routing information, and redundant links and core devices provide high level of resilience. So here redundant switching is also there. So how this can be happen, let us discuss. Initially we start with packet in the layer 2 switch, okay, towards the distribution a switch. The distribution switch performs multi-layer switching towards a core interface. Then the packet is multi-layer switch across the LAN core, and then the receiving distribution switch performs multi-layer switching towards an access LAN, and the packet is layer 2 switch across the access layer LAN to the destination host. So this is the way how we can perform multi-layer switching in the campus core. And finally, we are going to implement hierarchical routing in the WAN. With the help of, initially we start with packet is layer 3 forwarded towards the distribution router. Okay, the distribution router forwards the packet towards core interface. The packet is forwarded across the WAN core, and the receiving distribution router forwards the packets towards appropriate access layer router, and the packet is layer 3 forwarded to the destination host access layer LAN, and this process runs iteratively, and finally the hierarchical routing in the WAN can be implemented. In this layer, we have discussed distribution layer functionality, core layer functionality with hierarchical routing in the WAN. When we discuss distribution layer functionality, it covers distribution layer characteristics, policy-based connectivity, and distribution layer example. In case of core layer functionality, we have discussed switching in the core layer and multi-layer switching in the campus core. Using a modular approach to the network design will be discussed in next video. So bye bye for now. Thank you very much.